Well, what China has done is shown that they can do the same things that NASA and NASA's partners have been doing aboard the International Space Station.
One of the most highly anticipated and monumental upcoming rockets like the SpaceX Starship is none other than the latest addition to China's illustrious Long March lineage. The Long March 9, China's ambitious endeavor to send its own takeonaut to the moon, beautifully aligns with the debut of the Long March 9, a rocket poised to carry the aspirations and dreams of China's space programs, marking a historic milestone with the first Chinese national set to step foot on the lunar surface.
Let's look at the highlights of China's 2023 space missions in this episode of Tech Breakdown.
Today's episode will cover how the upcoming Long March 9 will be a total game changer for China's space program. SpaceX's Starship spacecraft and Super Heavy rocket, designed as a fully reusable transportation system, have garnered significant attention worldwide. With its remarkable capabilities, Starship has the potential to revolutionize space travel by reducing costs and enabling sustainable missions to celestial bodies like the Moon and Mars. In its reusable version, Starship boasts a lift capacity of 150 metric tons to low Earth orbit, LEO, which increases to 250 metric tons in its expendable form, while Starship dominates headlines and captures the imagination of space enthusiasts.
Look at the rebirth of our interest in returning to the moon with the Artemis program. We have rejuvenated our lunar space program right around the time when China says that's what they want to do.
It's crucial to recognize that the United States is not alone in its pursuit of super heavy rockets to reduce launch costs and facilitate missions to distant planets. China, a formidable player in the global space race, is also working diligently on its super heavy lift reusable rocket, known as the Long March 9. Originally conceived as an expendable rocket, the Long March 9 is set to become China's super heavy rocket with a capacity to launch 150 tons to LEO and 50 tons to lunar transfer orbit. A significant shift in design occurred around 2016 when China officially announced its intention to develop the Long March 9 as a reusable rocket during its Spaceflight Day celebrations on April 24. China's ambitious space endeavors are supported by its 14th five-year plan, 2021 to 2025, with reusable rockets identified as a key goal in the 2021 White Paper on Space Activities. The target launch date for the basic design model of the three-stage Long March 9 is 2030, with a two-stage reusable version planned for an initial launch in 2040. Recognizing the strategic importance of lunar resources, China is eager to establish a foothold on the moon. Proposals for lunar resource mining have been submitted to the Chinese People's Political Consultative Conference, CPPCC, National Committee, and the China Aerospace Science and Technology Corporation, CASC, is actively developing technologies to create a space logistics system spanning the solar system, potentially enabling China to reap economic benefits from space resources by 2100 or even earlier. To achieve these ambitious space goals, including a lunar research base, asteroid exploration, human missions to the Moon and Mars, and the construction of space-based solar power SBSP satellites, China sees the development of the Long March 9 super heavy rocket as a game-changing endeavor. The Long March 9 aims to support the construction of China's International Lunar Research Station, ILRS, by 2036, contribute to missions to Mars, and assist in the creation of SBSP satellites. According to Gu Mingkun, a senior rocket designer at the China Academy of Launch Vehicle Technology, CALT, the baseline model of the Long March 9 is projected to be a three-stage rocket measuring approximately 110 meters in length. Its capability to transport 50 tons to Earth-Moon transfer orbit is seen as crucial for establishing a lunar permanent base and mining facilities. The first model will feature a reusable first stage, and the second model will consist of two stages, both with a reusable first stage. This approach aims to significantly reduce launch costs for China. China's Long March 5, which can transport 25 tons to LEO and 14 tons to geostationary transfer orbit, costs approximately $3,000 per kg to LEO. In contrast, the Long March 9 is anticipated to halve that cost, bringing it to around $1,500 per kg to LEO, aligning it closely with Starship's cost estimate. Crucial technologies for the Long March 9 are already in development. For instance, the construction of a super heavy lift rocket necessitates large propellant storage tanks. CALT revealed the development of a 10-meter diameter rocket tank in March 2023, double the size of the tank used for the Long March 5. This project took 6 years to complete. Hu Zhengan, Deputy Chief Designer of Heavy-Duty Launch Vehicles, emphasized that the development of an ultra-large diameter tank structure for the Long March 9 demonstrates China's capacity for advanced manufacturing supported by an upgraded industrial base. China's efforts in reusable technology have also borne fruit. The YF-100N engine, developed by the Academy of Aerospace Propulsion Technology, exemplifies this progress. Featuring a 130-ton thrust engine, the YF-100N employed advanced techniques such as 3D printing, automatic welding, and intelligent assembly for its components. This engine will be used in the Long March 5G, expected to launch by 2027. The Long March 5G will be capable of sending 27 tons to translunar injection and will support reusable transportation to the Tiangong space station, as well as human missions to the moon. Reusability is one of the biggest factors going forward with Chinese space program. It is the linchpin in their quest for cost efficiency, sustainability, and enhanced mission frequency. By developing reusable rockets, such as the Long March 9, China can substantially reduce launch costs, opening up new possibilities for scientific exploration, satellite deployment, and lunar, even Martian missions. This strategic shift not only optimizes resource allocation, but also fortifies China's competitive edge in the global space race. Ultimately, reusability represents a pivotal strategy that propels China towards a more self-reliant and influential position in the realm of space exploration. China's ambitious plan to send humans to the moon by 2030 was officially confirmed by Lin Xiqing, Deputy Director of the China Manned Space Agency, CMSA. In May 2023, Lin outlined the mission's objectives, which include mastering key technologies for Earth-Moon manned round trips, lunar surface exploration, human-robot joint exploration, landing, roving, sampling, research, and return, ultimately establishing an independent capability for manned lunar exploration. The strategic goals of China's super heavy lift rocket, the Long March 9, are crystal clear. They encompass building the capacity to establish a lunar base, developing a presence in crucial gravitational stable zones like Earth-Moon and Earth-Sun Lagrange points, constructing space-based solar power satellites through in-orbit assembly and manufacturing, and maturing an end-to-end space logistics system at remarkably low costs. It is essential to caution against underestimating China's technological capabilities. The assumption that China will not achieve its reusable rocket goals by the set deadline is unwise. China has a track record of making strategic choices and implementing plans effectively in various domains, from shipbuilding technology to 5G networks, quantum-based satellites, methane rocket testing, and rare earth element supply chain dominance. China has consistently demonstrated its ability to excel and lead on the global stage. With the official commitment to building the Long March 9 super heavy rocket, supported by funding, policies, and regulations, China is poised to reshape the landscape of space exploration. Success in this endeavor could grant China unprecedented control over space access and utilization, solidifying its position as a dominant force in the final frontier.